Let us solve some problems on principle of linear superposition. Check if the system described by the response y, which is a function of t, for the input x, function of t for time, is linear or not. If so, the first problem is the second problem is x of ln t, and the third problem is x of sine of t. Now these are similar problems of the type x of some function of t, and f of t is t square in problem 1, f of t is ln of t in problem 2, and f of t is sine of t in problem 3. The fourth problem says that y of t is t into x of t. The fifth problem is the fourth and fifth problem again are similar. So f of t, x of t type, where f of t is t for problem 4 and f of t is t square for problem 5. The sixth problem is y of t equal to 2t plus x of t, and the seventh problem is of similar nature. So it is of the type f of t plus x of t, where f of t is 2t in problem 6 and f of t is t square in problem 7. So they are similar type of problems, and therefore we have clubbed them together. Two more problems. One is the 8th problem, which says that y of t is x square of t, and the 9th problem says that y of t is x of t. So we will solve these problems one by one. Answer to first problem, second problem and third problem, according to which y of t has the form x of f of t. Now let us make clear what is being given and what we are to find out. X of t is the input. It is the stimuli, and it is applied to a system, and the response of the system is y of t. Now y of t is related to the input or the stimuli in this manner. So this is the output, this is the response. We have to find out the nature of the system, whether it is linear or not. Now what is the role of S, the system? This is very clear. T in the input is replaced by f of t in the output. Here we have x, here too we have x. The change that occurs due to passage of this stimuli, say signal, through this system is that t is replaced by f of t. So we can write the role of S is t at input is replaced by f of t at output. So now let us check the principle of linear superposition, which means we have to check for law of additivity. Now this is one stimuli, this is another. These are the inputs which let us apply on the system individually or separately, and the response is that t will be replaced by f of t. And then according to law of additivity, what we have to do is we have to add them, and what we get is x1 plus x2, and we have to add these two and then pass them through the system, and the response is that again t will be replaced by f of t. So here we have to look for t. So here is one t, here is another. So the response will be x1 f of t plus x2 f of t. And we note that these results are same, and therefore law of additivity is obeyed, which means system is linear. Let us also check law of homogeneity or law of scaling. So let us check law of homogeneity or law of scaling. So the stimuli applied to the system, and the response is t replaced by f of t, and then we have to scale it, that is multiply by the scale factor k, and we get and then to the stimuli let us scale it, and what we get is k of x of t, which is passed through the system, and the response again will be replacing t by f of t. So it is now these two results are same, which means law of homogeneity or law of scaling is obeyed. So we conclude that system is linear, and the law of principle of superposition or superposition principle holds. Next, let us take up the fourth problem as well as the fifth problem. Here y of t is given to be f of t, x of t. Here x of t is the input applied to the system. We get the output, which is given to be f of t, x of t. And here we note that t in the input is replaced by f of t as a pre-multiplier to x. So this is the effect which the system has. on the stimuli. This is the response of the system. So the role of system is t at input is replaced by f of t as a pre-multiplier at output. Let us now check the law of additivity. So x1 of t and x2 of t are separately applied to the system, and what will be the response? The response will be replacing t by f of t as a pre-multiplier. So it will be f of t x1, and here it will be f of t x2. Now we have to add them, and that gives us this is the response. And if we add x1 and x2, what we get is, and when passed through the system again, replace t by f of t as a pre-multiplier, and we note that these two results are same, which means law of additivity is obeyed. We next discuss whether law of homogeneity holds, and it will hold because satisfaction of law of additivity implies that system is linear. So principle of linear superposition holds. Still, let us do it explicitly. So law of homogeneity, or the scaling, so x of t applied to the system gives, as before, f of t multiplying x of t, and then introduce the scaling to get kf of t x of t, and if we scale the input we get k of xt, and then pass it through the system to end up with which is same as the previous response. So they are same, which means law of homogeneity is obeyed. So the system is linear and principle of superposition holds. We are speaking of system represented in the problem 4 and 5. And now let us move on to the next problem, which is represented in 6 and 7. So answer to 6 and 7, where yt has the form so this is x, goes to the system, the response of which is y of t, which is f of t plus x of t. So the role of system now is to replace t at the input by f of t in the output as an added term. So t at input is replaced by f of t as an added term at output. Let us now discuss the law of additivity, whether it is obeyed by the system S whose response is of this pattern. So x1t, x2t, they are applied to the system, and the response is and here the response will be f of t plus x2 of t, and we can add them to get f of t plus f of t, so we'll have twice f of t. Now let us add. And as it passes through the system S, what will the response be? The response will be t replaced by f of t as an added term, so it will be f of t plus x1t plus x2t. It is clear that these two results do not match, so they are not same, which means law of additivity does not hold. So the system is not linear, and principle of linear superposition will not hold. Still, let us check the other law, law of homogeneity or law of scaling. So law of homogeneity or law of scaling the response is ft plus x of t and scaled properly we'll get k of f of t plus x of t. So it is kf of t plus kx of t. This is the response. But if we scale it, the stimuli, before application to the system, we have kx of t so this is what we get as a response. And obviously these two terms are not same, implying that law of homogeneity or law of scaling does not hold, does not obey for the system mentioned in 6 or 7. So we conclude that the system in this case is not linear, and principle of superposition does not hold. We come next to problem 8. So answer to the 8th problem, where it is given that y of t is x square of t. So this is the input applied on the system S, and the response is y of t, which is as given in the question to be x square of t. So clearly x goes to x square, which means the input is squared. So this is the input and this is the output. So input is squared after passing through the system. So it is very obvious that the system is a squaring system. Now let us check law of additivity, whether it holds or not. These are the two inputs on the system S, the responses being the squares, and we add them. And this is what we get. Now we add the stimuli x1 and x2 to get x1 of t plus x2 of t, which is passed through the system, which squares it. And we have an extra term compared to this response. So clearly the responses are not same because of this additional term, and this means law of additivity does not hold. Let us now check the law of homogeneity, or the law of scaling. So this is the stimuli which is applied on the system, and it being a squaring system, x goes to x square. Now apply the scaling. So what we get is k into x square t. Now scaling before passing it through the system means the stimuli is scaled to kxt before passing to the system, after which what we get is kx square, because it is a squaring system. X goes to x square, input is squared. Now this is k square x square t, and we note that these two are different, which means law of homogeneity is invalid for this system. So the system is non-linear. And this is what we guessed, because input is squared, it is a squaring system, it is not a linear system, and that is what we have proved. And further, obviously principle of linear superposition does not hold, it being a non-linear system. Let us move on to the ninth problem. So answer to 9, where we have yt to be xt. So xt on the system gives us an output which is equal to the input. So this means the system is invariant. The system gives a linear response, and let us check it. So x1t on system gives us response to be the same. So x1 goes to x1, here x goes to x. And similar is the case for x2. Upon addition we get x1t plus x2t, and if we add here, now after passing through the system, what we get is the same thing. So the responses are same, which means law of additivity holds, the system is linear. And it is trivial to show that law of homogeneity holds xt through system gives the same response, and if we scale it, we have kx of t. Here we scale the input, but after passing through the system we end up with the same thing, and the two are same, so this holds. So it follows that system is linear as we guessed or expected, and since law of additivity and law of homogeneity or scaling holds, principle of linear superposition holds.